What's up guys, welcome back to the channel. Today with this video we'll be doing this previous question paper that you see here. So this is a national certificate for mathematics and 4, and this question paper was actually written 20th November 2024. It took about 3 hours to be written. So on this particular video we'll be focusing on question 4 because I've already done question 1, question 2 and question 3. Just in case you want to watch those videos, you can go to the description. I've left the link that will take you to those videos, and also that playlist will also pop up on the top right of this video here. Alright guys, so before we start though, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I've done lots and lot of videos on mathematics and also on previous question papers just like this one. Now the last thing that I need to mention here before we start is I will leave the timestamps just in case you don't want to watch this video or the questions in a sequence order, so that you can select the specific question that you would like to watch. Alright guys, let's look at question 4 and let's see if we can able to solve the problems. Right, so here's our question 4. So question 4 consists of 5 questions. Now we have 4.1, 4.2, 4.3, 4.4 and 4.5. So we're going to start with question 4.1, which is this one here. We're going to copy this question, paste it where there is space and solve it. So let's copy the question. Alright guys, let's look at 4.1. Now 4.1, they want us to determine the following limit. Now the limit of this expression here when x approaches infinity. Now we have 3 methods that you can try in order for you to solve or find the limit of this expression. Now the first method, which is very simple, we call it direct substitution. Basically the direct substitution is you do a direct substitution. Wherever there is x, you substitute with infinity. So you can say 2 multiplied by infinity to the power of 3 minus infinity to the power of 2 plus 3 multiplied by infinity plus 9. Divide by 5 infinity to the power of 3 plus 3 multiplied by infinity minus 4. Now this method here, we're going to get infinity over infinity because anything multiplied by infinity, anything plus infinity, anything subtracted by infinity is infinity. So we don't have a limit when you use the first method, which is a direct substitution. Now let's do the second method. The second method, if the first method gives you infinity or 0, you go to the second method. Now the second method, you try to simplify this equation. Now when I look at this expression here, you cannot simplify because to factor the numerator, it is not that simple. It will have a remainder, and also to factor the denominator also. So you cannot simplify this expression. If the second method is not working, now let's try the third method. Now the third method is you divide each term with x that has the highest power. Now when you look at this expression here, the x with the highest power here is x to the power of 3. Each term here you will have to divide it with x to the power of 3. Now let's try the third method. Now here's how you're going to do it. You're going to start with the first term on the numerator, which is going to be 2x to the power of 3. Divide by x to the power of 3, because x to the power of 3 is the x with the highest power, minus. Now the second term of the numerator, we have x to the power of 2 divided by x to the power of 3. The third term is 3x divided by x to the power of 3 plus the last term on the numerator divided by x to the power of 3. You have to do the very same thing, divide by 5 x to the power of 3 divided by x to the power of 3 plus on the denominator, the second term, we have 3x divided by x to the power of 3, and then the last term we have 4 divided by x to the power of 3. As you can see, each and every term of this expression here is divided by x to the power of 3 because x to the power of 3 is the x with the highest power on this expression here. So this is the third method I'm talking about. Now if you continue here, let's look at the first term on the numerator. We have 2x to the power of 3 divided by x to the power of 3. This x to the power of 3, they will give you 1 multiplied by 2. So we're left with 2 here. And then the second term on the numerator, we have x to the power of 2 divided by x to the power of 3. So here we're going to left with 1 over x. And then we look at the third term on the numerator, this x, and then here we're going to be left with x to the power of 2. So we're going to have 3 divided by x to the power of 2. The last term of the numerator, there's nothing we can do there. We're just going to write it as it is, 9 over x to the power of 3. Divide by, we continue the first term, we have 5x to the power of 3 divided by x to the power of 3. X to the power of 3 divided by x to the power of 3, then we have 1 multiplied by 5. So we're left with 5. And the second term on the numerator, we have 3x divided by x to the power of 3. This is going to give us 3 divided by x to the power of 2 minus the last term on the denominator. We don't do nothing. It's 4 divided by x to the power of 3. Right. Now that we managed to solve it this way, the second step is to do direct substitution. Now, wherever there is x, we substitute with infinity. The first term on the numerator, which is going to be 2, we leave it like that. There's no x there. Minus 1 divided by. Now, the second term on the numerator, we have 1 over x. So wherever there is x, we substitute with infinity. There we go. Plus. And then the third term on the numerator, we have 3 over x squared. But wherever there is x, we substitute with infinity. Let's not forget this one is squared. Plus the last term, we have 9 over x to the power of 3. But this time we're going to put infinity to the power of 3. There we go. All this, we divide them. As we divide, we have 5 on the denominator on the first term. The second term, we have 3 divided by x squared, but we're going to say 3 divided by infinity squared. Remember that. Minus, we have 4 divided by x cubed, but we're going to have 4 divided by infinity cubed. Right. So there is another information that you need to know about infinity. Any number divided by infinity is 0. Any number. As long as you have infinity dividing them, it's going to give you 0. So let's continue. Let me create a space here. Now, as we continue here, the first term on the numerator, we have 2. The second term, we have minus. We have 1 divided by infinity. Remember, any number divided by infinity is going to give you 0. The second term also plus 0. The third term plus 0, because all of them, they're divided by infinity. Divide by. The first term on the denominator, we have 5. And then the second term is 3 divided by infinity squared. That is going to give us 0. The third term is going to be 4 divided by infinity, which is going to give us 0. So the final answer here, we have 2 over 5. So this is our limit. Guys, this question here, it was not really that difficult. All you needed to know is we have these 3 methods to actually find our limit. Just in case you didn't know, I've made a video explaining these methods on how to find the limit. Just for clarity, go to the description, click on the link of that video to watch the video, and also that video will pop up on the top right of this one here. All right, guys, this was not that difficult. All you needed to know is this method. Just in case it so happened that I didn't understand, leave a comment in the comment section and I'll try to explain to you to my level best. But if this video helped you to understand how to solve this type of a problem, please do not forget to leave a like, and also you can share. And if you haven't subscribed to this channel, subscribe to the channel. All right, guys, we are done with 4.1. How about we do 4.2? All right, guys, now that we're done with 4.1, how about we do 4.2? Now, as you can see, 4.2, we are given the following question here. So I'm going to copy this question, paste it where there is space, and we solve it. All right, guys, let's look at 4.2. Now, 4.2, they want us to differentiate the following with respect to y. Now, we are given this polynomial here. What you need to understand here, guys, this time around, they say with respect to y. Most of the time, we are used to differentiate with respect to x. They just swap things around. Before you do any deriving or differentiation, you need to look each and every term and start to notice which rule is it, and again, is this term need to be simplified or not. So when I look at this expression here, I can see that term number 2, it needs some simplification. Term number 3, it also needs some simplification. So you cannot differentiate yet without simplifying. So let's first simplify this expression here. When you simplify, you still say x is equaling to, because you're not yet differentiating. Now you rewrite the ones that are fine, like the first term, we have y to the power of 3, it's fine, and then we say plus. We cannot differentiate the second term like this because it has the exponent on the denominator, so the base must be on the numerator. So if we take this e to the numerator, it's going to be e, and then the sign of the exponent is going to be positive. It changes, so it's going to be 2y, right? Then we go to the third term. Again, the third term, we cannot differentiate with the trigonometric functions underneath there on the denominator. We need to simplify this. So in order for us to simplify this one, it's very simple. We just have to use the inverse. So what is the inverse of 1 over sec? If you still remember, 1 over sec is the same as cos, but then we have 2y. There we go. And then the fourth term is fine. We're just going to rewrite it like this. And then the fifth term is going to be fine like that. Just in case you didn't understand the third term where I say 1 over sec is cos, there is a video of inverses. I will leave the video on the description. Go and watch that video. And also the very same video will pop up on the top right of this video here, so that you can understand the inverses. Now that our expression is linear like this, we can start differentiating. Now do not forget, this is going to be dx over dy. There we go. We are differentiating with respect to y, so it should be like this. Now let's look at the first term. When we look at the first term, this here is a standard derivative. So when we differentiate the standard derivative, we're going to say 3 multiplied by y, 3 minus 1. That's what we do, right? Because it's a standard derivative. Then we go to the second term. The second term is exponential because y is an exponent then. When we differentiate the second term, we're going to say 2e to the power of 2y natural log e. Just like that. This is how you do the differentiation of exponential equation. Now let's go to the third term. Now the third term is a trigonometric function. Now we have cos 2y. So the differentiation of cos 2y is going to be 2. First of all, you multiply by this 2 here. And then what is the differentiation of cos? It's going to be minus sine. There we go. Right, now we go to the fourth term. Now the fourth term, we have 2 natural log y. Now this is a natural log differentiation. Now when you differentiate the natural log, it's going to be negative 2, and then you divide by y. The last one is going to give us 0 because there is no y here on this one here, guys. Remember, we are differentiating with respect to y, so this is going to give us 0. So you can continue and simplify this further. You can write 3y to the power of 3 minus 1, which is going to give us 2, plus you can say 2e to the power of 2y natural log e. But natural log e is equaling to 1. Even if you don't write it, you leave it like that. And then we go to the third term. Now the third term is 2 multiplied by negative sine 2y. So it's going to be negative 2 multiplied by sine 2y. And the last term is going to give us minus 2y minus 0. Even if you don't include this 0 here, it's fine because you already included the 0 there. Guys, this is how you do this one here. This polynomial, it was not that difficult to differentiate. It needed you to know each and every term, the type of equations that we have. We have the standard derivative here. We have the exponential derivative on the second term. We have the trigonometric derivatives on the third term. And we also have the log derivative on the fourth term. And the last term, it was a constant. So it needed you to know all the type of equations that were given here and the type of derivatives that you must apply. Just in case you don't know how to solve this problem, I'll leave a video where I solve a problem similar to this. In fact, I will leave the playlist where I have multiple of questions similar to this where I solve them. You can click on that link so that you can watch those videos on the playlist, and the very same link will pop up on the top right there with the playlist. Alright guys, I hope you managed to understand this. This was not that difficult. If this video helped you to understand, do not forget to like, share, comment, and also if you haven't subscribed to the channel, subscribe to the channel. So if it so happened that you didn't understand, do not forget to leave a comment as well, and I'll try to explain to you to my level best. Alright guys, we are done with 4.2. How about we do 4.3? Alright guys, we are done with 4.2. Now let's look at 4.3 guys. I'm gonna copy this question here, which is a 4.3, paste it with a space and try to solve it. Alright guys, here's our 4.3. Now 4.3, they want us to differentiate. Now we have y is equaling to natural log kx, and then they want us to use a function of a function, which is a chain rule. Now this question here guys, it needs us to use this method here, which is known as a chain rule or a function of a function. Now when you use this method, you must understand that you have the outer function and the inner function. Now the outer function, I'm gonna highlight it with the red. So the outer function is the whole thing from natural log kx. That is your outer function. Now the inner function is kx. So you must equate the inner function with u and the outer function with y. So for example, if we say u is equaling to kx, which is the inner function, therefore y is equaling to natural log u. If u is equaling to kx, y is equaling to natural log u. So we substitute here. So we use this method here. Now we need to differentiate both these equations. Let me start with u. When you differentiate u, it's gonna be du over dx. We are differentiating u with respect to x. What is the differentiation of kx? The answer is gonna be k. There we go. Now let's look at dy over du. Now this is a natural log. So when you differentiate natural log, it's 1 over u. Right, just in case you don't know how to do the natural log differentiation, you can go to the description. I made a video there, and also the very same video will pop up on the top right. It explains how the differentiation of natural log works. Now from here, to get your dy over dx, you must multiply du over dx with dy over du. Right, let's continue. I'm going to continue. Dy over dx. It's going to be, what is du over dx? Du over dx, if you can look here, is equaling to k. Multiply. What is dy over du? If you look here, dy over du, it's 1 over u. So multiply by 1 over u. Right, so if you continue, dy over dx is equaling to k over u. But if you go back here, what is u? U is k multiplied by x. So we have to substitute u with kx. So we can say k divided by, wherever there is u, we substitute with kx. We have kx. Then if you look at this, we have k divided by k. So the final answer, dy over dx, is going to be 1 over x. Guys, this is our final answer. I hope you guys managed to understand this one. It was not really that difficult. All you need to know is the chain rule, or a function of a function. Now, there are many ways of solving this, but this is the way that I could explain it better. So just in case you want to understand more about this chain rule, I've made a video explaining how exactly to identify and how to use this method. You can go to the description, click on that link where I explain the chain rule, and also the very same video will pop up on the top right of this one. Alright guys, if this video helped you to understand how to differentiate using the chain rule, do not forget to like and share the video. And also, if you haven't subscribed to the channel, subscribe to the channel. If it so happened that you didn't understand still, you can leave a comment in the comment section. I'll try to help you to my level best. Right, we are done with 4.3. How about we do 4.4? Right, we are done with 4.3. How about we do 4.4? Now we're gonna copy this question here of 4.4, paste it where there is space, and let's do it. All right, guys, here's our 4.4. Now 4.4, they want us to differentiate the following here. They say y is equal to e to the power of x divided by sec x using the quotient rule. Now this is one of the rules that you're supposed to use to differentiate this. Now before you differentiate this, you need to understand that you have your denominator and your numerator. Now you can say y is equal to f of x, that will be your numerator, divided by g of x, that will be your denominator. When you differentiate this using the quotient rule, dy over dx, there is a formula for it. You first differentiate f of x prime multiplied by g of x, then minus f of x multiplied by g of x prime, right? And then you divide by g of x, then you square that g of x. Basically, this is how you use the quotient rule. Now it means that we need to differentiate f of x and g of x. So we can say here f of x from this equation is equal to e to the power of x. And we can also say that g of x from this equation is sec x. There we go. Now from here, what can we do is we need to differentiate both of this. F of x prime is the same. It's going to be e to the power of x. As for exponents, this is the same. Just in case you don't know, you can go to the description. I've made a video explaining the differential of exponents. You can go to the description and also to the top right of this video. That video will pop up here. And then g of x is the trigonometric function. Now, how do you differentiate sec? So g of x prime is going to be sec multiplied by tan x, right? So now all you need to do is to substitute all these there. There we go. Now let's create a space. dy over dx is going to give us, what is f of x prime? Our f of x prime is going to be e to the power of x, or e to the power of x. What is g of x? Our g of x is sec x, so we say sec x, right, minus. Now the second term on the numerator, we have f of x. What is f of x? Our f of x is e to the power of x, so it's e to the power of x multiplied by g of x prime. What is g of x prime? Is going to be sec x multiplied by tan x, this one here. So multiply by sec x multiplied by tan x, divide by g of x squared. Remember, g of x is equal to sec, so you're just gonna write sec x, but do not forget that you need to square it. So this is your final answer. Guys, I wouldn't advise you to go further than this because they just wanted you to use the quotient rule. They didn't mention to simplify further. So this is how you actually differentiate this equation with quotient rule. I hope this helps you to understand how to do this one. Just in case you don't know what's happening here, I've made a video explaining the quotient rule. I'll leave that video in the description, and also the very same video will pop up on the top right of this one. Alright guys, if this video helped you to understand, do not forget to like, share, comment, and also if you haven't subscribed to the channel, subscribe to the channel. Right, we are done with 4.4. How about we do the last question, which is 4.5. Alright guys, now that we're done with 4.4, how about we do 4.5? Now this is the last question of question 4. So we're gonna copy this question here, which is 4.5, paste it with the space, and let's try to solve it. Alright guys, here is 4.5. They want us to determine the coordinates of the point of inflation of y is equal to x to the power of 3 minus 2x squared minus 8x with an aid of differentiation. Now, the point of inflation, guys, is a point at which the cubic graph, let's say for example like this one, where it increases or decreases. Let's say this is a point of inflation. In order for you to determine the point of inflation, you need to derive this equation twice. So that second derivative is actually equaling to 0. So d squared y divided by d x squared is equaling to 0. So the second derivative, just know that it is equaling to 0. So when you do the first derivative, let's do it here, dy over dx, we must use the standard derivative. So the first term is going to be 3x squared minus 4x. There we go. And the last term is going to be minus 8. So this is the first derivative. Now the second derivative, d square y divided by dx squared. The first term is going to be 6x minus 4. The last term is going to give us 0 because it's a constant. Let us not forget that the second derivative is equaling to 0. So when the second term is equaling to 0, we can say 6x is equaling to 4. If we take this 4 to the other side, it's going to be positive. And then we divide by 6 throughout. This is going to give us x is equaling to 2 over 3. Now this is the x coordinate of the point of inflation. Now if you are looking for the y coordinate of point of inflation, you need to go back to the original equation from the statement there. Wherever there is x, we must substitute with 2 over 3. Right, so I'm just going to do it here. Y is equaling to, the first term is x to the power of 3, where we can say 2 over 3 to the power of 3. Remember, x is supposed to be substituted by 2 over 3. The second term is negative 2 multiplied by x squared. So negative 2, wherever there is x, we substitute with 2 over 3. But we have squared there. Then we go to the last term where we have negative 8 multiplied by x. But wherever there is x, we substitute with 2 over 3. Right. So you punch this on a calculator. The answer that you're going to get is going to be. Now this is your y coordinate of the point of inflation. So you can say point of inflation is 2 over 3. That is your x, and your y is negative 5,93. Or you can write this 0,66 for your x, and your y is negative 5,93. So your x is this and your y is that. Guys, you really didn't need to do much when you solve this one here. It was really straightforward. All you needed to know is that second derivative is equaling to 0 when you are looking for the coordinate of point of inflation, and then you can solve for x after doing the second derivative because it's equaling to 0. And then you can use this x coordinate and substitute it to the original equation to find the y coordinate. And then you will have your x and y coordinate for point of inflation. And then when it comes to deriving here, this is a standard derivative, just in case you didn't understand this part here. You can go to the description. I left a video where I explain the standard derivative. And also the very same video will pop up on the top right of this video here. Alright guys, we are done with question 4. Just in case you have a question based on this question there, you can ask a question on the comment. And also if this question helped you to understand, or this video helped you to understand, do not forget to like, share, and also comment. If you haven't subscribed to the channel, subscribe to the channel, because I made lots and lots of videos on previous question papers and questions like this. Alright guys, we are done with question 4.5 and also question 4 as a whole. Thank you very much guys for watching. At the end of this video, there is a playlist that has question 1 to question 4. So click on that playlist just in case you want to watch all other questions then. Alright guys, I hope this helped you to understand. Thank you very much guys for watching. Till next time, cheers.